In this lecture, we are going to discuss on demultiplexers. So in the previous lecture, we saw multiplexers, and in that example, we had 4 cross 1, just a minute, 4 cross 1 multiplexers, right? 4 cross 1 mux, right? So in that example, you have seen that 4 inputs are, right, they are directed to one output, right? So one input here is available at a time, right? That is based on the select signal that is being applied to this, right? So S0, S1, right? So these are the two select signals. These select signals will select whichever the input should be displayed or given to the output line, right? So out of these 4 inputs, only one input will be available at the output O, right, at a time. So that is based on how you excite the select signals, right? In the case of demultiplexers, it is nothing but the reverse of the multiplexer. Demultiplexers have this configuration, right? So for example, if we take a 4 cross 1 mux, the DeMux will be 1 cross 4, right? So you'll be having one single output, one single input, right? This input I, right, will be given to any output line. For example, this is output line x1, x2, x3, and this is x4, right? So this input line can be connected with any output line, this, right? So if x1 is connected, so the rest of the others will not be connected. If x3 is connected, the rest of the three x1, x2, and x4 will not be connected. That is controlled by the select signals, right? So since we discussed about 4 cross 1 mux in the previous lecture, we'll discuss about 1 cross 4 DeMux in this lecture, right? The link is given in the description. If you have not seen this 4 cross 1 mux, you can go back and see, and you can come back to the lecture, or you can complete this and you can go to 4 cross 1 multiplexer, right? So we'll just expand this. Let's change the color for this. This is a 1 cross 4 demultiplexer. Just put it aside so we can operate on the truth table. So we need some space for it. Just put it here like this, right? So these are the inputs. As you can see, input is only one single input available for you, I, right? So one single input, right? So here in the output side, you'll be having 4 output lines. So 1 cross 4, right? So this is nothing but you can keep it x0, you can keep it x1, x2, and x3. So how will you now select the number of selection lines, right? So in the previous lecture we saw this 4 cross 1 mux, right? So we have 2 power and input bits, and n is equal to number of selection lines, right? So in the case of demultiplexers, right, you can see this formula, m is equal to log n base 2, where m is nothing but number of selection lines and n stands for the output lines, number of output lines, right? So m is nothing but which is equal to log 4 output lines, so log 4 base 2, right? So you can convert that into log 2 to the power 2, right? So m is now equals to 2, right? M is equals to 2. So 2 selection lines will be available for you. So selection lines, number of selection lines will be 2. So you can write it here. Select lines S0 and select line S1. Additionally, you will be given with this signal enable E, right? So if the E is kept low, right, so in spite of exciting this selection lines, the output will not be connected, input will not be connected to the output, right. So if E is kept high, then the circuit will start exchanging, right, the input will be connected with the output. Now we'll go for the truth table of this demultiplexer. So the truth table of the demultiplexer goes like this. So the first input will be, we'll start with the select signals first. So this is the S0. I will start with this. Draw the table. This is S0, S1, right? And the next one will be the enable E, right? Enable should be kept high all the time, right? So enable E and X0, X1, X2. The last one is nothing but X3. Now we'll see what happens. So in the beginning S0 is 0, S1 is 0, and E is also 0, right? So I told you in the beginning, if E is 0, so there is nothing will be displayed in the output side. Now since we have two combinations of inputs, S0 and S1, right, it can be 0 0 and can enable, the enable can be kept at high, right. If the enable is kept at high, 0 0 condition is given, right. Now the input is connected with the output X0, right. So the X0 will be 1 enabled, right, and the rest of the other outputs will be 0 0. The next input will be 0 1, enable is kept high. Now this input is connected with the output X1. So if now X0 will not be having any value, so it is 0. Now it is the turn for X1 and others are 0 0. The last one, next one is 1 0, right. 1 0 is connected and enable is kept high. What happens? So this is connected with, input is connected with X2. Now X2 will be enabled, the rest of the others will be disabled and there is no data for them. 1 1, right. So the last combination, and input is kept high, so 1 1 is kept high, 1 1, and 1 1 stands for 3. So the input is connected to X3, so 0 0 0 1, right. So this is the truth table for 1 cross 4 DeMux, 1 cross 4 DeMux. Now from the truth table we are going to derive equations for the outputs, right. So after deriving the equations we will make logic circuits. Equations go like this, and for the output x0 is equal to, just change the color, x0. So you get x0 will be enabled only when if you have E enabled and S0 is 0 and S1 is also 0, right. When you get S1, X1, you get X1, so X1 is here, right. S0 is 0 and S1 is also 0, so E should be there and S0 should be 0 and S1 should be high. And when you get X2, right, X2 is here, so X2 is obtained when S1 is high and S1 is low. And when you get X3 when there is, just forget to write the E, here you can see E dot S0 dot S1, right. After seeing, you can observe that X0, it requires AND gates, it is also requiring AND gates, right. So your logical circuit must be having 4 AND gates and 3 inputs, right. So these are the expressions you obtained from the above truth table. Now this is the time for the logic circuit. Logic circuit of this 1 cross 4 DeMux. So this is the input line S0, and draw a straight line for S0, and you can draw a straight line for S1, and you can put a special line for enable, that can be put it in green, right, giving a green signal, go. right? So this is enable. Enable should be always kept fine. We can put a different color for the AND gates, right? So we are having 4 AND gates, right? So this is AND gate 1, right? This is AND gate 1. Now from the expression you can see S0 exists as S0 as well as S0 bar, right? And also for S1 is existing as S1 and S1 bar. So you need inverters, right? We need inverters, inverting gates like this, and goes like this. Inverting gates. So we can extend this to the bottom. This also will be extended to the bottom. I'm sorry, this just a minute. Okay, yeah. So the first connection can be made like this. Right. I'll change the color. Right. So the first connection for S0. So take a tap from E. E can be connected in this way. And can directly connect E to this and S0 bar. S0 bar and can raise this to the bottom and put it below. Right, so you can take a tap to this. So this gives you X0, right, which is equal to S0 bar S1 bar dot E, right. So you can go to the second AND gate. Second AND gate goes like this, and we'll change the color. Okay. Right, so this is AND gate 2. Right, so this is AND gate 2, and it has the input from here, like this. Right, and the last one will be S1. So S1, take an input from the high signal wire, not the low signal wire, right? So this is X1. So X1 is nothing but E dot S1 low and S0 low and S1 high. And the last one, the next one will be the gate 3, right? This gate 3 will be having S0 from the high line, right? One from the enable, and one from low voltage line of S1. So this is X2. X2 is nothing but S0 S1 bar dot E, right? The last one, the final one of this circuit, fourth one, right? So directly tap an input from right. This is from the enable, and this is from S0, right? And you can tap one input from S1 also, right? So this gives you X3. X3 is nothing but enable dot S0 dot, right? So this is the logic circuit of 1x4 DeMux, right? If you have any doubts, you can put it in the comment section. Thanks for watching.